Thank you everyone for joining us today. During today's presentation, we will be discussing the importance of an accurate particle size analysis, the history behind the pneumatic sieving principle, the four main operating parameters to achieve an accurate, reliable particle size analysis. We will also be touching upon the benefits and limitations of pneumatic sieving and provide some real-life examples of applications that use pneumatic sieving process. Measuring particle size distribution and understanding how they affect your products and processes can be critical to the success of many manufacturing businesses. Particle size distribution and shape plays a part in many different applications. For example, it can determine the setting time of cement or the power of pigments, the taste of food, and even the effectiveness of drug delivery. Knowing and defining the particle size and material can increase the overall product quality and value. Industries rely on particle size analysis to produce accurate, reliable results that will save you time, money, energy, and resources. This is improving the production efficiency. Particle size distribution is designed to determine and report information about the size and range of set particles represented in a material. Particle size distribution determination has been used to monitor, control, and investigate material properties in countless of industries. Information defined from the particle size distribution includes the log normal distribution and the well-known and trusted Rosen-Ramler distribution method. There is a vast array of analytical techniques and equipments to determine the particle size distribution. In selecting the analytical technique or the particle size equipment, you must clearly understand the target or scope you're about to measure and the purpose of this measurement. 12-inch ruler is not a satisfactory tool for measuring mileage. Likewise, an instrument designed to measure particles in several hundred microns is unlikely to be of any help in determining the particle size distribution of a nanometer-sized powder. Thoroughly examining the properties and characteristics of the powder and the specifications of the analyzer ensures that this is really suited to that target and the purpose of your measurement. In today's presentation, we will discuss the pneumatic sieving technology and how it analyzes the particle size distribution in a material. Sieving technology has been around since the time of ancient Egyptians. They used a sieving system to measure and distribute grain for the production of bread and beer. It can even be considered the backbone of particle size technology. The Egyptians would grind the grain into flour on a hand mill and then place the grain onto a sieve, like the one pictured here on the right. Whatever material passed through the sieve would be used as the flour for the bread and beer, and whatever material was retained on top of the sieve would be regrinded. Fast forward to the mid-60s when the technology for pneumatic dry sieving was developed. It was developed as a more accurate method of particle size determination, and over the years, like technology, the equipment has evolved to meet current demands. While it's the simplest technique, it's also the most common because it can be used to analyze a wide range of materials in many different types of industries. The pneumatic sieving principle is when a positive airflow is introduced upward through a rotating wand that's located directly beneath a test sieve screen. As the wand rotates, it disperses and distributes the sample, allowing 100% of the particles to come in contact with the test sieve screen. The particles that are finer than the test sieve screen opening will pass through. The particles that are coarser than the test sieve screen will remain on top. The Mikro air-jet sieve is a device that utilizes the pneumatic sieving principle. In these next couple of slides, we're going to review the Mikro air-jet sieve, how it uses the pneumatic sieving principle, and the four operational parameters to be used as your basic guideline to ensure an accurate, reliable, and repeatable particle size analysis. Keeping in mind the importance of an accurate particle size analysis is to improve the product quality and increase production efficiency. The Hosokawa Mikro Airjet Sieve, also known as the acronym MAJSX, X standing for the model, analyzes dry powders ranging from 20 microns to 4,750 microns by using a short series of test sieve screens. The MAJSX is designed with an integrated analysis computer with touchscreen controls and user-friendly software with step-by-step instructions. The MAJSX can be operated in the basic or advanced mode, and it has the use of an optional high-efficiency cyclone that's seen here on your screen. This cyclone is used for a 98% product recovery of particle sizes 10 microns and higher. Before we begin the sieving process, we want to take a look at the 4 operational parameters that you should use as your basic guideline to produce these accurate, repeatable results. Sample size. When trying to produce repeatable results, you want to make sure you use the same sample size for each analysis. When performing the analysis on the Hosokawa Mikro Airjet Sieve, we suggest using sample sizes anywhere from 10 to 100 grams per cycle. This is product dependent. Product dependent meaning, if you have a product that's lighter in density, you're going to have a smaller sample size, let's say around 10 grams, and vice versa. If your product is heavier in density, you will have a larger sample size. We suggest the higher sample size of 100 grams because of the actual square footage of the test sieve screen. Should you have too large of a sample, when you place the cover on the test sieve screen, it might force the product through, blind the test sieve screen, which can then skew your results. We at Hosokawa suggest a sieving time of 120 seconds or 2 minutes per test sieve screen. It should be pointed out that a longer sieving time can improve the recovery of a given particle size for a distribution. However, excess sieving can lead to particle degradation due to attrition. This can be especially pronounced for particles near the tail end of the size distribution. The recommended sieving pressure is anywhere between 8 to 16 inches of water. Again, these parameters are product dependent. Should you have a friable material, you might consider running the airjet sieve at a lower sieving pressure, causing less attrition. Using the same sieving time and sieving pressure for each test sieve screen per each analysis will yield comparable results. The 4th and most important operating parameter is the integrity of the test sieve screen. I know what you all are wondering, and yes, this is a piece of Scotch tape that's on the test sieve screen pictured here on the left. We actually have had customers in the past damage their screen like this and proceed to put a piece of tape over top of it, and this will not yield reliable results, and yet customers and technicians time and time again will do this. Test sieve screens being used during the sieving analysis should not have any mars, dents, waves, or imperfections in the test sieve screen. You want your test sieve screen to look like this at all times, shown here on the right. Most people, when they think of stainless steel, they think it's indestructible, when in all reality, a 325 wire woven mesh, as you can see here on your screen, is as flimsy as the shirt on your back. It almost feels like a silk. It's only when it's pulled taut by the test sieve screen frame does it seem indestructible. My point being that test sieve screens can be damaged easily. Maintenance and care is the utmost important factor in the integrity of the test sieve screen. The only object that should come in contact with the wire mesh besides the product is the nylon brush provided with the MAJSX. Hosokawa supplied test sieve screens comply with ASTM E11-13 standards and are made with stainless steel frame and stainless steel wire mesh, ranging from 20 microns to 4,750 microns. They are serial numbered and certified to be at a specific level of compliance. Hosokawa sieve screens are supplied with a histograph and a certification to confirm that level of compliance. The test sieve screens should be cleaned once a week and recertified when necessary. To review, the sample size, sieving time, sieving pressure, and again, most importantly, the integrity of the test sieve screen are the 4 operational parameters to give you the most accurate, repeatable, reliable particle size analysis. When utilizing the pneumatic sieving principle in the Hosokawa Mikro airjet sieve, you always want to start with the finest screen first. When starting with the finest test sieve screen first, you're going to remove any fines from the product. This is going to eliminate any potential for agglomerations, which can skew your results. A frequently asked question from our customers is, can results from an airjet sieve be compared to that of a shaking or oscillating analysis? The answer is no. When using the shaking or oscillating method, it uses multiple sieve screens at a time, starting with the coarsest screen first, which is on top of the test sieve screen stack, and then ending with the finest screen, which is located at the bottom of the test sieve screen stack. While this method can work for certain materials, it's not the most recommended method because of the fines being removed last. For example, if your material being analyzed is extremely cohesive, it can cause the finer particles, which have a higher surface area, to stick to other particles, creating a large agglomeration, causing for skewed results. With an airjet sieve, we work with one test sieve screen at a time, and we remove the fine particles first, again to eliminate any potential for those agglomerations. During the sieving process, air is the only force that comes in contact with the test sieve screen. No mechanical intervention is needed. As you can see in this picture, and here where this red line is, the rotating wand is directing the airflow upward and is deblinding and dislodging any particles that may have become entrained in the test sieve screen. You can see the airflow dispersing the material across the sieve screen so that 100% of the sample can come in contact with the test sieve screen. As you can see here, the coarser material is being retained on top of the test sieve screen while the finer particles are passing through and being carried to either the high-efficiency cyclone or the vacuum. This is a close-up picture of the air wand. And here where the red line is where the air comes out of and disperses the material. The advantage with the MAJSX is that it is designed with a built-in sieving timer and modulating pressure valve, both which are controlled and measured by a software that was uniquely designed for the MAJSX. The software not only controls and measures 2 of the operational parameters, the sieving time and sieving pressure, it can calculate the percent of sample that is passed through or the percent of sample that is retained on top of the test sieve screen, whichever the operator defines as the scope of the analysis. This software eliminates the operator influence and any human errors that can occur, creating that accurate, repeatable, reliable particle size analyzer. The MAJSX has a compact design with an onboard single-board touchscreen computer with printing capabilities. It can communicate directly with a compatible electronic balance, and it has a quiet, clean operation. In other words, there's no dust during the operation, and the noise level is comparable to that of a normal household vacuum. Another feature of the MAJSX is that it can accommodate a 200 mm or a 203 mm diameter test sieve screen. This is your typical setup of an MAJSX. Here you can see the compatible electronic balance, again, which communicates directly to the MAJSX. And here this shows the optional high-efficiency cyclone, again, which can capture particles 10 microns and higher. And of course, the industrial vacuums, which is the driving force behind the air pressure that's created in the MAJSX. The benefits of the Hosokawa Mikro Airjet Sieve is that it's highly accurate. It can reproduce reliable results. The removals of the fines first during a multi-screen analysis eliminates the potential of agglomeration or cohesion to form larger particles. Since the Mikro Airjet Sieve utilizes the pneumatic sieving principle, the rotating air wand will dislodge and deblind any entrained particles from the sieve screen. It's essentially eliminating the collection of ultrafines that could also potentially stick to the bottom of the test sieve screen. It's a quick and easy method, saving time, money, energy, and resources, increasing production efficiency and overall product quality. While the pneumatic sieving principle is the simplest, most common technique, it does have some limitations. Sieve analysis assumes that all particles are round in shape and will pass through the square opening. For elongated and flat particles, a sieve analysis will not yield reliable results. Some powders can have a hygroscopic or electrostatic tendencies. This can pose significant analytical difficulties, especially in smaller sieve sizes. These types of samples may need to be analyzed in a wet state. Hosokawa does offer a wet sieving device for applications that require this form of analysis. This is why it's extremely important to clearly understand the scope that you're about to measure and the purpose of the measurement. Even though there is a vast array of analytical techniques and equipments to determine the particle size distribution, each technique is going to have its benefits and limitations. Knowing and controlling the particle size present in a material is most important for every step of the process. This includes, but is not limited to, controlling of incoming raw materials, product processing, product handling, and even the confirmation for the final product. Knowing the particle size of the product can and will improve the product quality and the production efficiency, which is critical to the success of many manufacturing businesses. As mentioned in the beginning of the presentation and throughout it, pneumatic sieving is the most common type of particle size analysis because it can be used to analyze such a wide range of materials in different industries. The next couple of slides, we're going to review the different types of applications and the different industries that utilize the pneumatic sieving principle and the Mikro Airjet Sieve. Believe it or not, some companies don't require to know the actual size of a particle in a material. Toner companies will perform an optical confirmation when performing this particle size analysis. Just by looking at the grain content that's retained on top of the test sieve screen, toner companies can determine if their product has an even consistency. And again with paint manufacturers, particles will scatter light in different ways depending upon their size. Paint manufacturers must achieve desirable light scattering effects in order to define parameters such as the tint on your car or the glossy finish in your dining room. I actually had a customer once who would sieve out the fines and then proceed to take a flashlight out and shine it onto the retains and compare which sample was shinier and brighter. In other words, the product appearance was more important than the particle size itself. Knowing and defining the particle size distribution in your product can have a huge effect on the quality of the product. For example, some companies will take a sample every 15 minutes from the material being produced on their mill. This will ensure that the mill that they are using is producing a consistent product. Cement companies will perform tests like these to ensure a small particle size. As a rule, which I'm sure many of us know, larger particles pack more poorly than smaller particles. By decreasing the particle size, it creates a higher surface area and the packing density is improved. Cement companies want a smaller particle when laying cement. Increasing the surface area and the packing density can eliminate any air pockets that can create a significant product flaw. I'm sure everyone here listening today knows someone with asthma or has seen someone use an inhaler. What you might not know is that the material in the inhaler is actually a powder. In order for our bodies to maintain the integrity of air supply, our respiratory systems are incredibly efficient at filtering out particles above a certain size. This will stop particles from entering and damaging our lungs. Orally or nasally inhaled drug manufacturers must ensure that the product is capable of penetrating the lungs. Knowing and controlling that particle size will increase the effectiveness of the drug delivery. Controversially, cleaning product manufacturers may need to provide extra controls in order to prevent inhalation of particles that are of a dangerous size. This can cause a major health risk. The size of particles can have a direct correlation with a customer's perception of the product and therefore the manufacturing company. This is particularly true in the case of food products, in which a particle size can impact the enjoyment of the product. For example, like coffee, with which particle sizes affect the flavors released in the brewing process. Another food example is sugar. Without sugar, there would be no chocolate, there would be no cakes, no cookies, and no diversion from the everyday afternoon meltdown, which should be kicking in any minute now. Depending upon the sugar and what it's being used for, the smaller particle size, the faster the sugar dissolves, whether this be in your mouth or in a dough. Small crystals feel smooth and dissolve quickly, while larger ones give gritty or crunchy textures. And finally, for the ladies in the industry, the use of micronized minerals in makeup produces a lustrous, smooth, glow-like finish to the skin and enhances the feel and the appearance of the final product. Large cosmetic manufacturers depend on micronized and sometimes nanoparticle-sized ingredients to achieve that fine product quality and those applied finishes. Thank you for joining us today, and I hope you enjoyed the presentation on the importance of an accurate particle size analysis. Knowing and controlling the particle size in a material will increase the product quality and improve production efficiency and the overall success of the company. With a long life and minimal downtime, the MAJSX is the economical and reliable solution to your particle size analysis needs. Should you have any questions, please do not hesitate to contact me, and below here is my contact information. Thanks again and have a great day.